This video I have also defined some examples of Laplace transformation. Okay, the question is earlier the first time I have defined the lecture 2 I have defined the example 1 2 and now from here and now I have defined also I want to clear you the shifting property. So Laplace e to the power solve this. Find Laplace e to the power minus t 3 hyperbolic sine hyperbolic 2t minus 5 cos hyperbolic 2. You solve this problem, okay, or you find out the Laplace transformation. Yes, so from this shifting property, using this shifting property you can solve this problem easily, because this is Laplace of Laplace of e to the power minus t 3 sine hyperbolic 2t minus 5 cos hyperbolic 2t. Yes, this can be written as, according to this we have first find out the Laplace of, this is f of, if you are operating this formula then this becomes f of, here is a is minus of 1, so this is here is become minus of t, therefore f of this become, if you operating this then this thing is becomes f of s plus 1, like that. Okay, according to this, so you have to find out this Laplace operator, that is we have to find out the Laplace. So we have first you have to find Laplace 3 sine hyperbolic 2t minus 5 cos hyperbolic 2t. This one. Okay, according to all these results, sine hyperbolic 2t, at usually in place of a here is 2 and similarly for, so this can be written as, this can be written as 3, linearity property, and now 2 by s square minus 2 square, minus 5, and here is also p by, sorry, not p, you have written here is s, so s by s square minus 2 square, or you can say that this is again is equal to 6, minus 5s, and divided by s square minus 4. This is, according to this is f of according to Laplace transformation, this is become f of s. Now from the shifting property, this result is equal to f of s plus 1, so this result can be written as, so according to your problem which is given as, so according to the problem this is equal to Laplace, Laplace of e to the power minus t 3 sine hyperbolic 2t minus 5 cos hyperbolic 2t, this is equal to f of, this become f of s, so f of s plus 1, so this can be written as 6 minus, in place of s is s plus 1, that is 5, s plus 1, s plus 1, okay, and now in denominator this is s plus 1 whole square minus 4, you get the result. You can solve it, now you get the result which is equal to 1 minus, you can solve it, 1 minus 5s divided by s square plus 2s minus 3. This is the result. Okay, very simple, because you apply the if you apply the shifting property then you can easily get the result. Okay, this is the form for this. Now I also want to give you some other example. Let us example 3 4. Yes, example 4. We also defined you a next example 4. Find Laplace transform of f of t where ft is given as cos t minus 2 by 3 pi. Okay, for t is greater than 2 pi by 3 and is equal to 0 for t is less than 2 pi by 3. Yes, now we solve this problem. Here we using the second shifting property. Okay, here we using the second shifting property. So let us suppose that Laplace, we here is 5, so we converted it in another term, that is let us 5. Yes, Laplace of 5t which is equal to, suppose that this is equal to Laplace of here is cos t. Yes, Laplace of cos t, yes, which is equal to, according to formula you know that this is s by s square plus 1 which is equal to f of s. Okay, now from the second shifting property, yes, which is defined as Laplace second shifting property from second shifting property, yes, we have Laplace, yes, Laplace ft is equal to e to the power minus 2 pi by 3 s f of s. Yes, f of s, and this is again an f of s according to the here is, this is f of s is s by s square plus 1, so this can be written as, again this can be written as e to the power minus 2 pi by 3 s, yes, 2 pi by 3 s and s by s square plus 1. Okay, now this is actually if you apply the second shifting property, then you easily you can form the result. Okay, second shifting property, or you can solve if you apply the whole thing, that is or, yes, or you can solve if you apply the whole property which is defined in the second shifting property, then Laplace ft, yes, or this is the result is clear. Okay, now if you apply this, you get this is equal to 0 to infinity e to the power minus st. Actually I have explained you different two types because you clear it, the problem. Yes, e to the power st f of t dt. Yes, in the previous, as you have to prove the second shifting property, 0 to 2 pi by 3 e to the power minus pt, so e to the power minus st 0 dt plus 2 pi by 3 infinity e to the power minus st cos, from here this is given as this one, yes, e to the power this one, this cos t minus 2 pi by 3 and dt. Yes, from the this is 0, therefore you can solve this. This is equal to 0 to infinity e to the power minus s. Yes, e to the power minus s, and we can substituting here. This is s, substituting t minus 2 pi by let t minus 2 pi by 3 is equal to x. So dt is equal to dx, and now this become minus s. Yes, and x plus 2 pi by 3. Yes, this thing, and operating on cos x dx. Yes, and this is the same as 0 to, yes, operating here e to the power minus, yes, that is 0 to infinity, or you can cite that no, this can be done. You can also, in the first step, you can also e to the power minus s 2 pi by 3. Okay, and here is the integral is only 0 to infinity e to the power minus sx and cos x dx. Yes, you can also, it's operated in another form, and now you can, if you solve this integral, this is Laplace of, yes, now 0 to infinity of this one, this can be written as 0 to e to the power, yes, e to the power minus s 2 pi by 3, and there is 0 to infinity, changing the definitive property, e to the power minus s t cos t dt. Definitely a to b f of x dx is equal to a to b f of t dt, correct? Like that, then this can be written as e to the power minus s 2 pi by 3, and this one is Laplace of, here according to a problem is which has problem here, this one is Laplace of this is e to the power this, and this e to the power minus t, that is Laplace of cos t. Yes, and cos t, which is equal to, here you have defined earlier s by s square plus 1. So this is again become e to the power minus s 2 pi by 3 s by s square plus 1. Yes, okay, on two ways I have defined you this problem. Like that you can solve the other types of the problem. Yes, okay, thank you. In this problem I think it is clear. You apply only the second chapter. Okay, thank you.